Welcome to the Python Basics in 30 Minutes course. Here you will learn the most important concepts to get you on your way to becoming a proficient Python developer with earning potential range of $70,000 to $400,000 per year. Python is actually a very old language, having been released in 1991 by Dutch creator Guido van Rossum. The name of the language was actually not based on a big snake, but on the comedy sketch Monty Python's Flying Circus. Guido created Python out of his need for a proper language like C, but one that was interpreted, easier to use, and more concise like a shell script. We'll be using Python 3.11.1, released in December of 2022, on a Windows PC using Visual Studio Code as the IDE or integrated development environment where all the development will take place. So you might be wondering, why am I using VS Code instead of PyCharm? PyCharm is much easier to set up when it comes to Python. It was built for Python development. Well, in this day and age, as a developer, you're expected to know more than one language to be successful. VS Code supports many languages like C, C++, PHP, Java, JavaScript, HTML, to name a few. I recommend you learn VS Code, which is quickly becoming the most popular IDE out there, and it is free. I'm so excited you're venturing into this wonderful world where you can create websites, work with AI, automate stuff, and earn a good living while having lots of fun. Welcome to DevTotal. Let's get to it. Browse to www.python.org/downloads. Click on Download Python. Once it's downloaded, open the file and run it. Make sure you check both use admin privileges when installing py.exe and also add python.exe to the path. That will add python.exe to the environment path variable. I'll show you that in a second. Let's install it. I always get so excited when I'm working on a new technology, just a new world that I'm venturing into. I'm going to click on Disable Path Length Limit. If that comes up for you, just click on that. And now the setup is done. Let's close this window. Now it's time to verify the Python installation. To do that, open up the command prompt. I already have it in my taskbar. If you don't have it, you can click on the search button and type CMD. And once that comes up, right click on it, right click on command prompt, and click Run as Administrator. Now type Python --version, and you should see the version that you downloaded show up. If you see that, you did a good job. Congratulations. Let's get back to the add python.exe to the path variable. You were asked to check or uncheck that during the installation of Python. Basically what that does is it adds the python.exe to the environment variable. To check that, click on the search, type env. Then you see this pop up in the menu, edit the system environment variables. Let's click that one. Click on environment variables. And then if you click on path in the user variables for Fred and we click on edit, you'll see these Python 3.11 entries that were made by the installer. Now, if we were to browse to that directory by opening up Windows Explorer, paste it in, you'll basically get to the folder that contains python.exe. So basically, whenever you open up that cmd.exe or the command prompt and you type Python, the system will look up in the environment variables any entry of that executable. And if it finds it in one of the directories, it will execute it. So in that case, it's finding it here in this folder. Now it's time to download Visual Studio Code. To do that, browse to code.visualstudio.com/download. Click on the Windows download. This is for Windows versions 8, 10, or 11. Open the file. Accept the agreement. Next. I recommend creating the desktop icon and keeping the add to path checked. And click on install. And let's launch it. Now we got to install the Python extension. To do that, go to the menu there on the left and click on extensions, or you can open it by clicking Control Shift and X at the same time. And let's type Python. And the one you want to download was developed by Microsoft. So let's install that. Let's go ahead and configure the Python interpreter for this Python extension in VS Code. To do that, you got to open the command palette. There's a shortcut, and that is Control Shift and P. Press all of them together, and then type Python select interpreter, and it should pop up. Click on it, and the entry of your Python installation should show up at the app data local programs Python 311/Python directory that we configured earlier in this video. So click on that. Finally, it's time to start coding. I recommend you create a folder on one of your drives. Probably it's going to be the C drive. Just create a folder called DEV for dev. You can really call it whatever you want, but I use this a lot. And then underneath that, create a new folder, call it Python. Open that folder. Then go to VS Code, click on File, open folder, and browse to that directory. And you want to go ahead and just highlight the folder you want to open, which in this case will be called Python. Select it, click on Trust the Authors, and yes, I trust the authors. Now let's create our first file. File, new file. Let's call it Hello World.py. Make sure it's being saved in the Python directory you created. It's a great file. Go ahead and type P in your hello world.py file. The IntelliSense or Code Complete window will pop up with possible entries. So as you continue typing, the set will become more limited. Okay. This is very useful. A language usually has many different classes and functions and so forth, and this is a good way to kind of figure out what you need to use. You can also see the actual signature of this function, what types it accepts and so forth. If you don't see this IntelliSense popping up after you type P, you can type it and then press and hold Control and a space together, and that should force it to come up. So in this case, we're interested in the print statement. So click on print, open parentheses, and we want to print out hello world. Something like that, okay? You don't have to put a semicolon at the end. Python does not work with semicolons. So to run it, click on the play button at the top right, and you'll see the terminal opening up, and you see it's running out of our dev Python directory using the Python executable, which is referenced by the path environment variable that we set, and it's running that hello world.py file in there, and it's just printing out back to us exactly what we put inside these double quotations marks of the print statement. Sandra is very happy because she just won Employee of the Month. How does she know? She saw her name written on the whiteboard. The whiteboard saves and communicates this information to all of those that have access to look at it. Essentially, the whiteboard acts as a placeholder where Employee of the Month winner names are stored for a specific time period. The next month, Dan might win this honor, so the whiteboard will be erased and his name will be written there. Variables in programming are similar to a whiteboard in that, number one, variables store information for a specific period of time. Instead of the storage media being ink and a whiteboard, it will be bits stored in RAM or random access memory on your computer. Number two, variables convey information to other components that have access to them. Number three, variables can change the information stored. They can change over time. They are variable. Python uses four main data types, namely string, integer, Boolean, and float. Let's start with the string data type. So we first declare the variable name. In this case, it's going to be employee name. If your variable name consists of more than one word separated with an underscore, this is called snake case, and it's the recommendation for variable naming in Python. And then usually I put a space, equals space, and in this case we're going to assign a string data type. So I'll have to put it in double quotations and give the name of the employee. Okay, and then if we want to print that out, we can just say print, open parentheses, employee name, close parentheses, and we click play, and we see it's printing Dan. So that is an example of a string data type. Integer data type will look like this. So let's say employee underscore age, again the snake case, is equal to 40. Now we say print employee age. We get 40 returned. Let's do a float. By the way, the pound sign in Python denotes the start of a comment. It will not be executed as part of your code. So a float, employee salary is equal to $100,000.50, something like that. And there we see we print it out. One thing you'll notice is you don't really have to declare the data type before. You don't have to say like this is an int, you know, whatever. Python will automatically look at what you're sending into the variable or assigning to the variable, and then assign it as a data type. Okay, so in this case, when we assign 40 to the employee age variable, it sees it's just a whole number, right? So integers are essentially whole numbers. If you assign like a number with a decimal, then it becomes what is known as a float. Okay, and the last type will be Boolean, and Boolean is essentially true or false. So you can say employee active, maybe if they're still at the company or not, then you can just say is equal to true with a capital T. You can also set false. Okay. So we print that out. It'll just give you back what you sent it. Now, if for some reason you have, some class where you have a bunch of different variables declared and you don't know what data type it is, you can do something simple like print back the type of it. So you can just say type. This function is called type, and you pass in the variable that you're interested in. Okay. So you see over here, it's printing out, it is a string type, which is essentially a class. And now let's do it for the rest of them. Age, salary, and active. If we run all this, we'll see the string type, then the integer type for the age, then the float type for the salary, and then the Boolean type for the employee active. Now the real fun starts. Let's go over conditional statements in Python, specifically the if-else statement. I'm going to start by defining a few variables. Employee underscore first underscore name using snake case, space equals space, and let's give this employee the first name of Binky. Yes, I know I'm weird. Then employee underscore last underscore name is equal to Dinky. And let's give the age of this employee 40. And then we're going to set, if this was, let's say, an HR system that wants to determine if an employee is eligible for retirement or not, we'll set a variable for that. Retirement age is equal to 65, I believe is in America. Now, if else statement starts here. If the employee age is greater or equal than the retirement age, and then you add a colon, enter, and Visual Studio Code, it will actually automatically indent after you type if. So that's really cool. And then you can put the print statement, which is, let's print out employee space. And then we want to concatenate. To do string concatenations, you just use the plus sign. And then we'll type the employee first name plus, and then we want to have a space in between the first name and the last name. Concat again, employee last name plus double quotes space is eligible for retirement. And then we'll do an else colon, and I'm just gonna copy and paste this print statement to make my life easier. Is not eligible for retirement. Okay. If we go save this and we run it, we'll see the print statement. Binky Dinky is not eligible for retirement. Now, why is that? It's because the employee age of Binky Dinky is currently 40 and the retirement age is 65. And when we do the comparison logic over here, we're saying, is the age of the employee greater or equal than the retirement age? It's not. So we flow into the else statement. Okay, if we were to change the employee's age to 65 or higher and then run this, we'll see that now the first part is true because 65 is greater or equal than 65, and then it jumps in here. Okay, let's add another print statement to the if block. Congrats. Let's run that guy. Oops, we got an error. This error is because we did not indent the second print statement. So the compiler is complaining. Let's add a space. We're still having an issue. It's because the unindent does not match any outer indentation level. So we have to make sure that this second print statement is at the same level as the first one. And you see the error just went away and everything looks good. So indentation is very important in Python and it has to be done at the correct level. You can also move the first print statement and just put one space in there and do the same thing with the second one. And now the compiler will know that these two statements are associated with this conditional statement. And they both will be run if this part over here, the first if, is true. Now in Python it is recommended to either put 4 spaces or a tab if you're using Visual Studio Code. A for loop in Python is used for iterating over a sequence, and that could be either a list, a tuple, a dictionary, a set, or a string. A real life example would be you go grocery shopping and you put your groceries in the bag, and then you would enumerate all the groceries that are in that bag. So similarly in computer science, loops are used to iterate over objects. Let's go ahead and create a list. We'll call it employee names to hold a list of employee names. To create a list, you basically open the brackets and then you enclose, it could be string objects with double quotation marks with commas in between them. If we wanted to see what type of object this is, we can use the type function. If we run this, we see it's a list type. Okay, and to iterate over this list, you'll say for, and then you define a temporary variable. So this could be employee name, singular, in, and then you type the list variable name. So that will be employee names, plural. The one we defined up here is over here. Colon, just like in the if-else statement. Enter, make sure you indented 4 spaces or a tab, and then we can just print it out, the employee name. Let's run that. And there you go. It prints back Dan, Sandra, and Binky, the names in the list. Let's evolve our HR application. Instead of manually declaring the values for the employee name, let's allow employees to input their names. To do that, we use the input function. And if we run that, the terminal window pops up and it asks the employee to enter the name. So let's say Sandra and enter. Okay. So basically what happened was that the value that the employee input was saved in the employee name. To demonstrate that, we can output it. We can say print the employee name is, and then we concatenate it with the employee name variable. Let's run that. Sandra. Then you can see here the value of the employee name variable is being sent back. Let's take it a little further and ask the employee to enter their age, and then we're going to compare that to a retirement age to see if they're eligible for retirement. So declare another variable at the top called retirement age. We set that to 65. And let's ask the employee for their age. So we set the variable employee age is equal to, and then the input function, open parentheses, double quotations, enter your age. And then let's alter this print statement to include the values of both variables. Employee name. And then we add the age variable, years old. Okay, let's try that out. So we enter the name, Dan. Let's enter the age of Dan. Let's say 55. Dan is 55 years old. Let's now compare the employee's age to the retirement age and then print out if they're eligible for retirement or not. So to do that, first we're going to set a Boolean variable is equal to, and then we're just going to compare the employee's age if it's greater or equal to the retirement age. Okay, let's run that. So we enter the name, we enter the age, and we get an error. So the type error, the greater or equal operator not supported between instances of string and int. So what's happening here is whenever you use the input function, that value is assigned as a string to that variable. Okay, so that data type of the variable on the input function will be of type string. And what we're trying to do here is compare the employee age, which is currently an int because it's automatically assigned as an integer because it's a whole number, and we're comparing an int with a string because of this assignment over here automatically converts the data type of employee age to a string. That's not working. So what we can do is a data type conversion, and we'll just use the int to force the employee age to be converted to an integer. Okay. Let's run that. There we go. No more errors. Let's wrap up this me application. We want to now print out whether the employee is eligible for retirement or not. I'm just gonna paste in this code in the interest of time. Let's run it. Enter the name, Dan, the age, 70. Dan is 70 years old, and the employee is eligible for retirement. It's been a privilege to go on this Python journey with you. I wish you the best in your future endeavors. This is DevTotal, over and out.